The challenge of innovation in really aviation systems is that there's a fundamental difference between what a lot of people think about as innovation in the IT space and whatever. If I want to create some innovative web app or something like that, I can just do it. It doesn't work, okay? In what we do, if you do something and it's wrong, people might die. So, there's this tension of how do you innovate in a space which is safety critical. So I want to bring that technology in, but I don't want to screw it up. And we have an interesting sort of tension in civil aviation, the high-end civil aviation, is we are so safe. It's unbelievably safe. But we actually don't know exactly what makes it that safe. So there's a natural reticence to go too far out of the box in an operational system. So there is a challenge on how do you inject innovation into an industry that's a safety critical industry. So it's fundamentally different. Now, unmanned air vehicles create an opportunity because I can fly them, I can test them and things like that. But if you're going to carry people, or if you've got a vehicle which could be a threat to people, then you need to figure out how you're going to manage that innovation. So it's really different. It's also a challenge in terms of the return times on investment, because if I invest in some web startup and it works, it'll take within a very short time frame. So a lot of investors have developed expectations which are in very short cycle times. If I develop a new aircraft, let's just say I have some new electric vertical takeoff and landing aircraft, in order to get that vehicle to a point where it's developed, all the bugs are ironed out, I've gone through certification, I've developed the market, and send it, we're talking a decade or two. Very few investors are willing to hang in for that long time on sort of the startup. So it's an interesting space and time. There are opportunities. And we do see a lot of investment in some of these things in terms of long-range investments. But in order really to get to something that's in the market is a huge challenge in this industry. And I think you see similar things in the automobile industry. So one of the technological opportunities that we see when we look at air transportation at a broad level is really the use of data analytics, data mining techniques. If you think about air transportation, we have a huge amount of data. Every airplane that flies has a flight data recorder that's being sampled, hundreds of times a second, depending on the parameter you look at, and thousands of parameters are being monitored. Every airplane, the commercial airplane that flies, is being tracked by radar systems. We are influenced by the weather and the environment. So there's huge data sets that we have available. We really think that you can take advantage of looking at those data sets, if you can get them and frame them correctly, to find opportunities to improve efficiency, safety, and probably environmental impact of air transportation. So let me give you a few examples. So in terms of flight safety, we have flight data recorder systems that are used on board the airplanes, and we typically use these for accident investigation. That's why they're originally on board. Now, every airplane in the world pulls their flight data recorder in something called a quick access recorder. And typically that's used to discover or see if known violations occur. So you'll have what's called exceedance limits. If you pulled too many Gs, if you hit too hard on landing, if you over-temped your engine, you can look for those things. Those are fairly easy to identify. One of the things that's happened in aviation is we're incredibly safe. And we become safe by fixing problems we know about. The things that we're worried about now is what are the problems we don't know about, for which we don't have an exceedance, we don't have a simple algorithm to look for. So we've been using some of these data analytic techniques to identify what we call anomalous flights. What we do is we look at the data. There's a lot of detail on how we organize, but we organize the data reference to takeoff and landing. And then we have, let's just say, there's thousands of parameters, but let's just say there's 100 parameters. So what we do is we sample each parameter at some time interval out from the reference time. And what that does is that gives me a sample of data from that flight in a very high dimensional space, maybe a million dimensional space. And then what we do is in that space, we look for clusters of flights. So you'll have flights that are taking off from a high altitude airport, which will look different from flights that take off from a sea level airport, which will look different from flights that are taking off at low payloads, for example. And then what we can do is we can look at flights that are not within any of the clusters. So we isolate those flights. And again, remember, you have thousands of parameters. What we then do is we identify which parameters became unusual for an expert, because if you have a flight that's anomalous, it may be anomalous for a benign reason, or it may be anomalous for something that's a safety concern. So this is a way that we've developed to look at flights that are unusual, to try to look at precursors of aviation risk.